Homework 7 is kind of half mixed numbers, half order of operations with fractions. And mixed numbers, when you're adding or subtracting them, you can end up having to, Alex calls it renaming. That to me is sort of an old-fashioned way of saying regrouping. So we're going to see how we might get an answer when we add that we have to regroup. You can think of it as like you're carrying a whole number. So here's a couple of examples of answers we might get when we're adding two mixed numbers. If you have something like 4 and 5 over 3, this is a mixed number, but we wouldn't consider it to be simplified because the fraction 5/3 is improper, meaning the numerator is larger than the denominator. So we don't like that. We want the fraction to be proper. So what we can do is regroup the kind of whole number part of this, because 5/3 or an improper fraction is greater than 1. So we're going to regroup this, the 1 of this, I guess, into the 4. So you can think of this as like 4 and then plus 5/3. And 5/3, if you think about converting 5/3 to a mixed number, 3 goes into 5 once with 2 left over. So 5/3 is the same as 1 and 2/3. So now we're going to regroup the 1 into the 4 and add it to 4 basically. So this is actually 5 and 2/3. And I'm sorry, my writing's not great right now. I'm having issues with my stylus. Okay, so then for this other one, so just by the way, you might also have the problem that your fraction isn't simplified. And so in this case, this 12 and 16/10, we have both problems that our fraction's not simplified and this is improper. So it doesn't matter which thing you do first. I'm going to simplify it, that way the numbers are a little smaller. So 16 and 10 are both even, so this will simplify to 12 and 8/5. So now I can also notice that 8/5 is improper, and I can write it itself as a mixed number. 12 plus, so 5 goes into 8 once with a remainder of 3, so that's 3/5. And if you need to, when you're doing that, converting the 8/5, you can kind of do a little long division. So 8 goes inside the box, 5 goes on the outside. And so just, write it all out. 5 goes into 8 once. 1 times 5 is 5. Subtract, and we get 3. And so the quotient is your whole number part. The remainder is the new numerator, and you always keep the same denominator. So 1 and 3/5. So now 12 plus 1 is 13. So 12 and 8/5 is the same, equivalent to 13 and 3/5. But this is considered simplified because the fraction 3/5 is proper. Okay, so let's put this with actually doing some addition. 9 and 7/8 plus 6 and 5/8. So you could probably just add across. I learned to write these vertically, these mixed number addition and subtraction problems. So that's what I'm more comfortable doing. So and it's kind of like you're lining up place values. So you can think of the fraction as a place and the whole numbers as place, its own place. So 9 and 7/8, and then plus, I'm going to line up the 6 under the 9 and then the 5/8. And you'll get to ones where you do have different denominators, and so you'll just have a initial step of rewriting your fractions with the same denominator. But we don't have to do that for this one. So we can go ahead and add 7 plus 5 is 12 over 8. So remember, when you're adding or subtracting fractions, you don't change the denominator, it just tags along. And then 9 plus 6 is 15. And so now we look at our fraction and notice it actually can be simplified, and it can also, it's also improper. So 12/8 would simplify to, let's see, 4 goes into both of these, so 3 over 2. So this is the same as 15 and 3 over 2, but 3 over 2 is 1 1/2. 2 goes into 3 once with 1 left over, so this is the same as, oh shoot, that's not what I want. I want an equal sign. This is the same as 15 plus 1 and 1/2. So finally, 15 and 1 is 16 and a half. And pretty much all these problems that you're going to do with Alex, it's the improper fraction will always convert to a mixed number that has the whole number part 1. So that if you kind of know that, realize that, then you know that if you're going to have an improper fraction here, your answer is going to be add 1 to this whole number here. So 15 plus 1 is 16, and then actually let me go over here. And then the new numerator is what you get if you just subtract 3 minus 2. And also it'd be perfectly fine, at the risk of making this video go on forever, to do that whole regrouping process before you simplify. So if I know 12 over 8 is improper, I don't know why I just wrote 15, because I know it's going to go to 16, pretend that looks like a 6. So then 12 minus 8 is 4 over 8, but 4 over 8 simplifies to 1/2. So if you are comfortable doing it a little more quickly, then do it, but if you want to write out all the different steps, that's okay. You'll get comfortable at some point. Okay, so let's do one more, and I'd advise you to pause the video and try this one on your own, and then restart and see how you did. So 4 4/5 plus 3 3/5. And I'm trying to line up my whole numbers and my fractions. And I notice that I have the same denominator, which is good. That's what I need in order to add. So I can immediately add my two numerators, 4 plus 3, and get 7/5. And then coincidentally, we have 4 plus 3 for our whole numbers, so we get 7. So it looks like 7/5 is already simplified, or reduced, you might say, but it's an improper fraction. So this mixed number is not considered to be simplified. So we know, basically, because if you add two proper fractions, you're never going to get a number that's 2 or more. So I know that this is going to convert to a mixed number that's 1 and something over 5. So 7 plus 1 is 8, 7 minus 5 is 2, and 5 is going to be my denominator. If you want to do it more slowly, though, you can think about, you can even write out converting 7/5 to a mixed number. 5 goes into 7 once. 1 times 5 is 5. Subtract, and I get 2 for a remainder. So this is 7 plus 1 2/5. And so then the 1's going to regroup into the 7 to make the 8, and we'll have the 2/5 left. So you can see kind of over here with this long division how it works, that you're just going to end up subtracting to get your new numerator. And so I'm going to do another video that shows you a couple where you do have to find a common denominator first and then go through this process.